To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
So my dear children, in the previous chapter, we answered the fifth question, which is the first and foremost essay type question in the second paper. Now, within this chapter, my dear children, we'll be writing down the answers for the second question, the sixth question in the essay type question of 2022 O-level paper. So, when you look at this question, my dear children, the question is mainly focused about the chemistry lesson parts that we have learned within the grade 10 and grade 11. Okay. So, if you refer the first part, my dear children, in here, there are certain energy level diagram, there is a certain energy level diagram given. Then a reaction between octane and oxygen is given over here, right? So, based on the hydrocarbons and about the energy level diagrams related to the chemical reactions, right? The first part of the question has been created, okay? So, this when you go and focus with the second part, my dear children, part B. So, within the second part, my dear children, there is a certain structure given related to the, right, a certain structure given, which is related with the formation of or creation of a certain gas, right? So, gas production is the part which is focused over here mainly. So, you have to write down the answers for these chemistry question given in here then, okay? So, when you answer in the chemistry questions, my dear children, it is somewhat easier than the biological ones, because you know that when answering the biological questions, my dear children, we need to remember out each and every function, parts, adaptations and so on. But however, these things are like patterns, so we can write down the answer quite easily if you know the pattern perfectly, okay? Right then, so let's head on to see the questions, my dear children, right? And we'll answer the questions, and like in the previous one, you'll be getting 20 marks for the question number 6 also. So we'll answer the questions and finally we'll give out the marks for the correct answers at the end of the lesson, at the end of the discussion in the sixth question, right? So now let's head on to see the first and foremost question given under the sixth question, right? At present, light automobiles are run mainly by burning fossil fuels such as petrol, which is gasoline, right? In America, my dear children, usually this petrol is referred to as gasoline, right? Then the hydrocarbons octane C8H18 is the main component contained in petrol. Octane. So the question is mainly focusing about the octane, right? Petrol. So it's a hydrocarbon, my dear children. It is an alkane. How can you say that it is an alkane? When you look at the name octane, at the last part of the name, there is A-N-E, ane. So it's an alkane, right? So by using the name tag, we can find out whether it is an alkane, alkene, or else an alkyne, right? Alkynes are not given in your syllabus, but however, there are 3 types of hydrocarbons, right? Mainly we are focusing about alkanes and alkenes. So let's see what is the question given under the petrol thing. Let's see. Briefly explain. So explain briefly what hydrocarbons are. So you need to explain what are hydrocarbons, right? You need to explain what are hydrocarbons. So let's explain what are hydrocarbons. When you take a certain hydrocarbon, can you please if you can remember out what are the hydrocarbons, my dear children? You know that hydrocarbons are the ones which has carbon and hydrogen, right? Carbon and hydrogen. Hydrocarbons carry carbon and hydrogen. So in simple, right, we can describe hydrocarbons as the organic compounds, simplest organic compounds. These are the simplest organic compounds that has only carbon and hydrogen, okay? So we can write down the answer, organic compounds, right? Organic compounds. Organic compounds. that contain only carbon and hydrogen, right? So organic compounds that contain only carbon and hydrogen. This is what do you mean by a hydrocarbon, right? So these are organic compounds. That means, my dear children, the main constituent compound is, or main constituent material or substance is carbon. Then organic compounds that contain only carbon and hydrogen. These are hydrocarbons. Hydrocarbons, right? Next one. Based on the common formula of alkanes, verify that octane is an alkane. So, what do you mean by an alkane, my dear children? Alkane is a certain hydrocarbon that has only single bonds among the carbon-carbon atoms. All the carbon-carbon atoms are bonded with one single bond. That's it. So, that kind of a structure is called as an alkane. The common formula, now they are asking about the common formula by using the common formula. So the common formula for an alkane is, now if you take the smallest possible alkane, that's methane, which is CH4. Over there, 1 carbon and 4 hydrogen. 1 carbon, 4 hydrogen means, my dear children, 1 carbon, then 1 times 2 is 2. To be 4, we need to add again 2. So the common formula for a hydrocarbon, alkane of, right, hydrocarbon which is an alkane, okay. So common formula for an alkane is CNH 2 times N plus 2. That means 2N plus 2. This is the common formula for an alkane. If you take a certain alkane, always the carbon count, if you take carbon count as N, then hydrogen count is equal to twice of that value plus again another 2. Okay. That means the number of hydrogen atoms contained within a certain alkane is equal to twice of the carbon atoms and again another plus 2. So we can write it like this: C to the power CnH2n plus 2. This is the common formula. Let's substitute. Okay, now you know that oct means 8. So let's substitute 8 for this thing, and we'll see whether we can get the formula or not. So C8 H 8 into 2 plus 2, C8 H18. If I'm going to take you to the previous slide, it is given as C8 H18. See, which means, my dear children, based on the formula, common formula for an alkane, when we take the common formula for an alkane and if you substitute 8 for the number of carbon atoms, C8H18 could be obtained. C8H18 is octane. So therefore, octane is an alkane. Okay, right. Name a hydrocarbon that belongs to the alkane series and exists in the gaseous state at room temperature. Very simple, my dear children. First, second, third and fourth, all of these things, that means carbon 1, carbon 2, carbon 3, carbon 4. The first 4 alkanes, all of these alkanes are in the gaseous state. Okay. So you need to write down only how much? You need to write down just the one. A hydrocarbon, no, that means just the one. But however, all of these things are correct. Methane, ethane, propane and butane. Propane and butane are the ones which are included in the LP gas, liquid petroleum gas, right? You know, in simple, gas cylinders, right? Propane and butane are mixed to a certain proportion over there. So those things are gases. So all the 4 alkanes starting from methane to butane, right? All of these first 4 hydrocarbons, alkanes, are in the gaseous state. So we can write the answer. I'll just write down 1, methane, the most common one, CH4. However, these things are also correct. I'll mention those things as well. Ethane, right? Then propane, and also butane. One of these 4 is correct. Right, then next one. The balanced chemical equation relevant to the complete combustion of octane is given below. So this is the complete combustion of octane, my dear children. 2 moles of C8 and H18, that means octane, reacting with 25 moles of oxygen gas to produce 16 moles of carbon dioxide and 18 moles of water. So the question is given, calculate the mass of carbon dioxide released to the environment by complete combustion of 1 mole of octane, and the relative molecular mass of carbon dioxide is given as 44. So my dear children, first of all, we'll take the ratio between these 2 substances. What and what? They are asking about carbon dioxide and, my dear children, 1 mole of octane. So, first of all, according to the balanced chemical equation, we'll take the ratio between CO2 and this C8 and H18, which is octane. So, CO2 is to octane. Ratio goes like this. Carbon dioxide 16 moles given. 16 moles given. When reacting 2 moles, okay, here 2, you can see that. 2 moles of, we are now reacting 2 moles of C8 and H18. So this is the ratio between their moles. Okay, this is the ratio between their moles, my dear children. So the question is asking 1 mole of octane, when completely burning 1 mole of octane, we need to calculate the mass, okay, mass of carbon dioxide given out. First of all, let's see how much is the number of moles given out when burning 1 mole of octane. So for 1 mole, right, for 1 mole, when you divide this one by 2, we can obtain 1. That means we need to divide the other side also by 2. That means 16 division 2 is equal to 8. So 1 mole of C8H18 will result in combustion, or during the combustion of 1 mole of C8 and H18 will result 8 moles of what? 8 moles of carbon dioxide. Now you need to calculate the mass of this 8 moles. This is moles, number of particles. So we need to convert that thing into mass. When converting this thing into mass, my dear children, we need to get the relative molecular mass of carbon dioxide. If you put grams to here, then my dear children, always there is 1 mole of substances. You take the relative molecular mass and include grams for that thing. Okay? If you take the relative molecular mass and if you include for the same answer grams, then always the number of moles contained for each and every substance, this is okay. Take the relative molecular mass, include grams, then in that amount of mass, you can observe 1 mole of substance. That's the idea. So 1 mole is equal to 44 grams. You need to find out the mass of 8 moles over here. 8 moles of carbon dioxide. So CO2, this is referred to as the molar mass, right? Molar mass. So we need to find out the mass of 8 moles then. So to find out mass of 8 moles, what you need to do is you take 8 and multiply it by how much? 44. You multiply it by 44. So 4 times 8 is 32. 2, 3 is left over. 4 times again 8 is 32. 32 plus 3, 35. So our answer is 352 grams. 352 grams. This is the answer. How did I took it? Once again, get the balanced chemical equation. Write down the ratio between the two substances which the question is being asked with. The two substances are carbon dioxide and octane. According to the balanced chemical equation, write down the ratio between their number of moles like this. Then find out how much is 1 mole with respect to the other one. Then, my dear children, according to that ratio, get the relative molecular mass, put grams, then you can find out how much is the mass of 1 mole, which is the molar mass. Then multiply it by the relevant number of moles to get the entire mass of the substance. Okay, this is how you can find out the mass of a certain substance according to a balanced chemical equation, right? 352 grams. Next question then. Balanced chemical equation relevant to the complete combustion of octane is given below. Okay, once again, this is the octane. So the balanced chemical equation for the octane. Okay, now you already know that it's going to react like 2 octane molecules with, or 2 octane moles with 25 moles of oxygen to create 16 moles of carbon dioxide and 18 moles of water. Now the next one, the important one. An incomplete energy level diagram relating to complete combustion of octane is given below. Copy it in your answer script and complete. So you need to copy down this thing. When burning a certain fuel, my dear children, you know that octane is a fuel. When burning a certain fuel, heat energy is given out. That's why the engine is start to heat up, right? That's why the engine is getting heated up. That's why the silence of the vehicle is getting heated up, because of the heat energy which is produced during the chemical reaction. So burning any kind of a fuel can be expressed as, or it can be named as an exothermic reaction, because the heat is getting excited over here. Heat is giving out over here. So it's a exothermic reaction. It's an exothermic reaction. So exothermic reaction means, my dear children, right, according to this diagram, the products has very less amount of, now these are the reactants, no. However, the products, I'm talking about the products. Products has very less amount of energy when you compare it with the reactants. That's why to balance that amount, the heat is given out. More heat, more energy contained within the products, more energy is contained within the, not in the products, right? More energy is contained within the reactants, less energy is contained within the products. So to balance out this thing, what will happen? Heat energy should given out. Heat energy should be released to the environment, and it should be lowered to this level. That's how we represent these things in a energy level diagram. Okay, so here they have mentioned the first one. We have to complete the other part, my dear children. So first of all, we'll reduce this line somewhat. Okay, now we'll draw the second level like this. This is the second level. Right, then it's going down like this. What are the products created? Given in here, 16 carbon dioxide which is in the gaseous form, plus 18 water molecules, which is in the liquid state. Okay, now no need to write down actually this one, but however, if you can mention it, then it is much better. Heat is given out. Heat energy is given out, right? So when converting these reactants into these products, heat energy is given out. That's why the energy is getting reduced when converting these things into products. Okay, when you add this one with the heat energy given out, it's equal to the total energy carried out by the reactants. So this is the energy level diagram, my dear children, right? So we have successfully answered the first and foremost part of the question. Now it's time to answer the second part, part B, the gas production. Apparatus set up by a student to collect a specifically measured volume of carbon dioxide gas using the method of downward displacement of water is given below. So the student is preparing carbon dioxide gas, my dear children, like this. Okay, so he's using calcium carbonate, and there's disulfonal, and my dear children, the liquid that should be added to this one should be an acid. Okay, hydrochloric acid, right? So there's a graduated tube, then there's a water throw, and there's a delivery tube. Okay, right, so let's see the questions. Dilute hydrochloric acid is allowed to drip on the pieces of calcium carbonate through the disulfonal, and carbon dioxide gas is produced by the reaction between those two. What change should be made in this setup to prevent the escape of the gas produced through the disulfonal? There should be a change that we need to make in this setup, right? When you are adding acid into this one, my dear children, what will happen here is, if the acid level is, right, if the acid level is somewhat like in this, I'll draw it. If the acid level is like in this kind of a level, what will happen? The gases which is getting produced within the conical flask will escape through the disulfonal. It will definitely escape through the disulfonal, right? So in order to avoid that thing, what should we need to do? We need to take the disulfonal below the level of the liquid which is in the conical flask. You have to take it even below, right? We have to take it below the liquid level. Otherwise, the gas which is getting produced over here will going to escape and go out from the disulfonal. Okay? So, what do you need to do? Insert the disulfonal, right? We need to insert the disulfonal into the disulfonal into the liquid level, or into the liquid. That's enough, right? So that's the correct way. So if I'm going to draw it down, it should be like this. If you want, you can draw and show as well. It should be like this. Yes, this should be the way, right? It should go below the liquid level, right? It should go below the liquid level like this. So insert the disulfonal into the liquid, right? That's the correct way of doing the experiment. Or into the acid, that's also correct, no problem. It's important to insert this thing because otherwise the gas which is getting produced in the system will escape out through the disulfonal, right? Okay, next one. So what is the advantage of using a small conical flask rather than large conical flask here? Very simple, my dear children. What's the importance of using a small conical flask over here? Because here we can use within by using less amount of reactants, right? We can do the certain, or we can collect the certain amount of carbon dioxide without any trouble. And the other thing is that if you use large, right, a larger when container, right, then sometimes impurities will get collected with the carbon dioxide gas. Okay, so because of that also we won't be able to collect a pure sample of carbon dioxide, right? How, and also it will take much longer time to react, right? So by taking a smaller conical flask, what will happen, we can speed up the process of the chemical reaction. And the other thing is that the purity of the sample or the gas sample, that is also going to increase. And the other main important thing is that by using less amount of reactants, we can produce more amount of products, right? So I'll write the third one. Less amount of reactants will enough right? Less amount of reactants will enough to produce the gas sample. Less amount of reactants will enough to produce gas sample. Okay, other than that, you can write less time is being consumed. Okay, the purity of the gas sample is going to increase. Those things are correct. Okay, right. So they have asking only just one single advantage. So less amount of reactants will enough to produce gas sample. That's a good advantage. Okay, right. So the next question. Write the balanced chemical equation indicating the reaction between calcium carbonate and hydrochloric acid. So we'll write down the balanced chemical equation. Hydrochloric acid, HCl, in the aqueous form, plus calcium carbonate, CaCO3, in the solid state, limestone, right? So what are the substances created? What are the substances created, my dear children? The substances which are getting created from this reaction is, with the reaction between calcium and chlorine over here, right? Calcium and chlorine over here, calcium chloride is created. Calcium chloride. Calcium chloride, first of all, CaCl2 in the aqueous form. Calcium chloride, because the valency of calcium is 2, valency of chlorine is 1. When you interchange those two, CaCl2. Okay. Then next one, right? Water, H2O. Then finally, carbon dioxide gas, right? Okay, so this is the reaction. Now you need to balance this one. So you have to write down the balanced chemical equation. No, so we'll need to balance. We need to balance it. There's 2 chlorine over here, so I'm going to put here 2. Now let's see whether it is balanced. 2 hydrogen, okay. 2 chlorine, correct. Calcium, 3 oxygen, 1 and 2, correct. So it is balanced. You just need to put 2 to HCl, so it is automatically getting balanced after that. So this is the balanced chemical equation for the reaction between hydrochloric acid and calcium carbonate to produce carbon dioxide gas. 2 moles of hydrochloric acid reacting with 1 mole of calcium carbonate to produce calcium chloride, water, and carbon dioxide. Okay. Right. Next question. If equal mass of powdered calcium carbonate was used instead of pieces of calcium carbonate, required volume of the gas can be collected in a shorter period of time. Explain briefly the reason for this. Now, if we use, my dear children, equal masses, there is no difference in masses. They are mentioning that equal masses. Then powdered calcium carbonate and pieces of calcium carbonate. If we use powdered form means, my dear children, the surface area of the substance is very high. Now, if we use powdered calcium carbonate over here, powder form, that means the size of the particle is very less. Okay, size of the particle is very less in the powdered form, my dear children. So, when reducing the size of the particle, the surface area of the substance is getting increased, right? Can you remember we learned about the substances when we are learning about the rate of reaction, my dear children? We have studied that smaller the size of the particle, right? If it is in the same mass, then, my dear children, the surface area is going to increase, right? Surface area is going to increase over there. When increasing the surface area, the collisions between the particles, right? So, collisions between the particles will increase. Therefore, reactants will speedily getting collided with the particles, or the collisions, number of collisions that will happen within the reaction, reactants will get increased. Because of that, within less time period, more amount of products will get created, right? So here, mainly it's going to change the surface area of the substances. And because of change in the surface area, my dear children, or because of increase in the surface area, my dear children, what will happen? Due to increase in surface area, substances will react quite faster, and the products which is getting created will also get increased, right? So this is the answer, right? So we'll write the answer, my dear children. It will increase the surface area, it will increase the surface area of the reactants. Therefore, collisions between reactants will increase and products will create quickly. Right. So it will increase the surface area of the reactants, right? Surface area of the reactants will increase. Therefore, collisions between reactants will increase and products will create quickly. This is why, right, when you put like powdered form of calcium carbonate, the efficiency of gas, the removal of gas will get an increase. That's why it is getting increased, my dear children, because here when you take the surface area of the substance, it's getting increased when the particle size is somewhat smaller, right? Okay then. Name another method for collecting carbon dioxide gas when the measurement of the volume of gas is not required. So, name another method of collecting carbon dioxide gas if the measurement of the volume is not required. Okay. Carbon dioxide gas. When you take carbon dioxide gas, the relative molecular mass of carbon dioxide gas is 44. Relative molecular mass is 44, my dear children. And the other thing is that if you take carbon dioxide gas, my dear children, right, it is the mass of carbon dioxide gas, because of the increasement of the relative molecular mass, the mass of 1 mole of carbon dioxide is also very high when compared to the other gases in our atmosphere, which means, my dear children, it has a greater density. Density of carbon dioxide is very high because of the higher mass, right? So, because of that, my dear children, because of having higher density, carbon dioxide is located very lower in the very lower level of the atmosphere, right? In the very lower levels of the atmosphere, as it is very heavier. So, by using that property, my dear children, what property? The density, right? We can collect the carbon dioxide gas without using the downward displacement of water. If you put carbon dioxide like in this kind of a way, we can keep carbon dioxide without any problem. Because of the heavier mass in carbon dioxide, air will come out from the, right, normal air will come out from the vessel, because carbon dioxide is heavier than normal air. So, carbon dioxide will settle down in the bottom of a container and normal air will displace out. Okay. Like this. So, normal air displays up, right? Air displays up. Then carbon dioxide coming from the delivery tube will settle to the bottom. So, this method is referred to as air displays up. So, upward displacement of air, right? Upward displacement of air. Upward displacement of air, right? This is the answer. So, air displays up, settling carbon dioxide at the bottom. This is the upward displacement of air, right? The method. Next one. What physical property of carbon dioxide gas is made use of in the method you stated in the part A above? What physical property of the carbon dioxide? What is the physical quantity, my dear children? The density. Because of the higher density, carbon dioxide settles down in the bottom of the container. So, high density. High density, right? This is the answer. Then the next question. State a test that can be used in the school laboratory to identify carbon dioxide gas and the observations of it. Very simple. Since grade 6, you are learning this thing. When you bubble colorless lime water through when you bubble carbon dioxide through colorless lime water, my dear children, right? When you bubble, that means you just take a sample of calcium hydroxide, which is also referred to as in common lime water. You bubble carbon dioxide. You know that our exhale gas contain carbon dioxide. So you blow carbon dioxide. That means you bubble the exhale gas into a sample of lime water solution. Then what will happen? Automatically the color, usually it is in the colorless nature, so that colorless nature or the colorless lime water will turn into milky white or cloudy white, my dear children, right? It shows the presence of carbon dioxide. Okay, then we'll write down the answer. When CO2 is sent through colorless lime water, right? When CO2 is sent through colorless lime water, colorless lime water turns into milky white, right? So when carbon dioxide is sent through colorless lime water turns into milky white, right? This is the observation, and this is how we can identify carbon dioxide gas in the laboratory, in normal school laboratory conditions. And there's another method, my dear children. You know that carbon dioxide is not a supporter of combustion, and it is also not a combustible gas. And because of that, because of those features, my dear children, when you insert a glowing splinter or else a lighted splinter into a container of carbon dioxide, automatically the flame will get put off, right? The flame will get extinguished. It's mainly because of those features, because it is not a combustible gas, and it is also not a supporter of combustion. Because of those properties, right, what will happen if you insert a certain glowing splinter or else a burning splinter into a container of carbon dioxide, automatically the flame will get extinguished. Okay, that is also a experiment that we can carry out in our school laboratory to find out the contents in a sample of carbon, if it is a container of carbon dioxide. Okay, that's also a experiment that we can carry out in our normal school laboratories, right? But however, the perfect one is this, my dear children. That's why I have mentioned it. Okay, right. Then let's head on to see the next question. State an instance where non-combustible property of carbon dioxide is made of. So like I said, the non-combustible property of carbon dioxide, it's not a combustible gas, and also it's not a supporter of combustion. Because of that, my dear children, you know that we can use carbon dioxide to put off fire, right? So put off fire. Right. So my dear children, we have answered all the questions related to the chemistry question, which is the 6th question in the paper. Now let's head on to see how the marks are given for the questions given in the 6th question. Okay, so I'll be there with you with the marking scheme there. Right, my dear children. So now let's give out the marks for the correct responses. Okay, so for the first one, for explaining what these hydrocarbons are, you will be getting 2 marks. 2 marks for this question. Next one, for mentioning the common formula and verifying that octane is an alkane, my dear children, right? 2 marks are given, 1 each. Okay, so for writing down the common formula, 1 mark. For getting the answer through the substitution, again 1 mark. So 2 marks are given for this. 2 marks. Then for naming a gaseous substance or else a gaseous hydrocarbon at the room temperature, so these responses are also correct. However, you need to answer only 1 no. So for mentioning this thing, you will be receiving 1 mark. Okay, 1 mark. 1 mark. Next one. So here 2 marks are given, my dear children. Okay, 2 marks are given for writing down this thing, 1 mole equal, for 1 mole 8 moles thing, or for writing down like directly 16/2 equal 8 moles, that is also correct. For writing down this thing or this thing, okay, you will be receiving 1 mark. Then after that, my dear children, for the calculation and getting the answer, you will be getting 1 mark. So altogether, you will be receiving 2 marks for the calculation for 352 grams. Okay. Next one. The energy level diagram. So to mention in the energy level diagram, my dear children, you will be receiving 2 marks. They have specifically mentioned here for the reactants and, okay, for the in the reactants and in the products, you need to definitely mention the states. It's very important to mention the states in a chemical reaction, my dear children. It's very important. But however, usually for our O-level syllabus, for some kind of chemical reaction, it's not important to state the chemical the state. But however, when you take energy level diagrams like this, it's very important to mention the states, okay, state of the chemical substance. So they have specifically mentioned here for mentioned in the states of the reactants and products, right? 1 mark for mentioning the, for mentioning what? For states. Okay, for states 1 mark. And again, for showing this arrowhead downward, for arrowhead down, you will be again receiving 1 mark, right? Down arrow. For the states and mentioning the correct order of substances, 1 mark. Then for mentioning the arrow down, 1 mark. Okay, so altogether you will be receiving 2 marks for this question. 2 marks. Okay, then the next one. So for writing down this particular explanation, the error in the setup, or else for drawing the structure, 1 is enough. You will be receiving 1 mark. This is also correct. Drawing the structure is also correct. For that thing also, you will be receiving 1 mark. Right. Next one. So for writing down an advantage of using a small conical flask, they have given 1 mark for you for the correct answer. Then, my dear children, for the next one, for writing down the balanced chemical equation, they have given 2 marks. 1 mark is to balance, right? For balancing 1. For balancing 1 mark. Then for reaction, right? For reaction, again 1 mark. So altogether, you will be receiving 2 marks for this particular question, right? 2 marks for particular question. So for writing down the reactants and products correctly, that means for the reaction, you will be receiving 1 mark, and for the balancing part, you will be receiving 1 mark. Right. Then the next one. So in the next one, for explaining this process, right, because of the increasement of surface area, right, for writing down this particular sentence, increasement of surface area, 1 mark has been given, right? Then after that, because of increasing collisions thing, for the increasing collisions, right? So for that one, for that particular point, again 1 mark is given. So altogether 2 marks for the question. So see the key points. So you have to mention these key points when answering the questions, my dear children. So increasing of the surface area, they have given 1 mark, and because of the increasement of the surface area, the collisions between the reactants will increase. For that one also again 1 mark is given. So altogether 2 marks is given for the question for these 2 key points. Okay, right. Next one. Then the next one is given for the upward displacement of air. 1 mark is given, right? 1 mark is given. Then for the high density, again 1 mark is given, my dear children, for the correct answer. Then, my dear children, the next one. So for the experiment to identify the carbon dioxide gas, 1 mark is given for the experiment. 1 mark is given for the experiment, and for writing down the observation, again 1 mark given. So altogether 2 marks for the question. 2 marks for the question altogether. So this is the experiment: bubble in carbon dioxide through colorless lime water, or else you need to send this carbon dioxide through the colorless lime water. So for that thing 1 mark is given. Then for the observation, colorless lime water turns into milky white. For that thing, again 1 mark is given. That's the observation. Then, my dear children, for the final one, to put off fire, 1 mark. So altogether 20 marks for the 6th question. Right. So we have answered successfully the 6th question in the essay type question paper in 2022 O level. Right. So my dear children, with that one, I'm going to finish up this chapter also. Within our next chapter, we'll discuss the next question.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.